Hi all, welcome to module P9. In this module, we'll be getting an introduction to what SQL is and doing some quick exercises with SQL. So main objective is to understand what SQL is and what kind of queries we can do with it, and we'll be making several different kinds of queries. To recap what we've understood so far, we know why we need a database. We've also understood some basic data modeling concepts. We've gotten some basic familiarity with using a DBMS and also managing a database. This is what the architecture looked like. We had a browser. Using the browser, we went to a web app, which was db.imat.husurapp.io, which was serving an application called AdMiner. Now, this application was a PHP web app, which was talking to the Postgres DBMS, taking results from the Postgres DBMS and sending it back to us. So, if we look at how AdMiner, which is the web app, is communicating with Postgres, AdMiner is a web app which is actually a client and the DBMS is the server. So the AdMiner client makes a request to the DBMS server and the DBMS server returns a response to the AdMiner client. This communication happens over a different network protocol, which is not HTTP. For Postgres, in fact, it is called the Postgres protocol. It is a protocol on top of the TCP protocol. Like how HTTP is a protocol on top of the TCP protocol, AdMiner sends an SQL query to the Postgres DBMS and the Postgres DBMS responds with a result. So the language in which the web app is making queries to the DBMS is SQL. This is similar to how when we make HTTP requests, we make HTTP requests that have a particular format. For example, we make a GET request with a URL. Our request contains a URL, it contains a path, it contains headers, it contains a body. Similarly, the request that is sent from AdMiner to the DBMS contains SQL. Now, what is SQL? SQL is a special purpose language. It is a declarative language. It is not a procedural language. So with SQL, we can specify what we want to do as a result and we can declare our action, but we don't need to describe how the action needs to be done. We'll understand what this means in a little bit and you'll get a sense of this. There are two quick definitions that are important. SQL is both a DML and a DDL. A DML is a data manipulation language. So it is a language to manipulate data, meaning to select, insert, update or delete data. A DDL is a data definition language, which means a language to define the schema or the structure in which data is stored and to change that structure in which data is stored. So SQL allows us to do both. It allows us to, for example, in this box, insert a value into a table or select a value from a table, but it also allows us to create a table. So let's quickly try this out. I head to my iMat console, go to the database console, I log in here. Let's look at the article table. So we have 4 articles in the article table. I'm going to open this in a separate tab. So the SQL command window, I'll open in a separate tab. And now instead of using the UI to select this data, let's try to use SQL to select the data. So I'll say select star from article. And let's see what this does. This selects the 4 articles that we have. So let's read this SQL query. We're saying select, which is an SQL keyword. So we're saying select star, which represents all columns. So select all the columns from, which is again an SQL keyword, from the table article. I can make this query a little better and I can say select ID, title from the article. So we'll just select 2 columns from the article, right? In fact, I can select also only the title. So each of these is a SQL query that we made and it returns a result. As you can see, the result that is returned by an SQL query resembles a table and is exactly the same at a logical level, is exactly the same as a table, right? So the output is also in a tabular format. Let's try to now make an insert request. So this is what an insert request looks like. I'll say insert into, and then I'll give it the table name. So table name article. I then have to give the columns that I'm inserting. I have to name the columns that I'm trying to insert into. So let's check out what the columns are. So the columns are ID, title, content, author ID, and category. So ID, title, content, author ID, and category. And I'm inserting into this article table the values, and now I'm going to list out all the values of this particular row. So I'm going to create a new ID, let's say 99. The title of my article is article 99. The content is also article 99. The author ID is 1, which is an integer, and the category is, say, personal, right? And once I execute this query, you can see that I'm inserting into the article table. And let's refresh this to see if the insert has gone through. We can see that a new row has been created. Now, the interesting thing is that we actually don't need to insert an ID value, right? So, because the ID is set to auto increment. So I can remove the ID column and I can remove the ID value from here. Let's try inserting again. And you can see that another article has been created but has been given the ID 9 because that's what our last auto incrementing number was at. Let's now look at a different request. Let's look at an update request. So let's do update article, set category equal to work, where title equal to article 99, right? So in this query, I'm trying to update the article table. In the article table, I'm trying to set the value of category to work, and I want this to happen for all the rows in the article table only where a particular condition is met, which is where the title should be equal to 99. Otherwise, the article should not be updated. So let's try to execute this query. See that it says query executed, 2 rows affected, because I had 2 rows with the same title. So now if I look at the old data, it says the category is personal. If I refresh this, you can see that the article is changed to work. I can now also issue a delete request. So let's do delete from article where title equal to article 99. So again, it says 2 rows affected. Let's look at this. And you can see that both those rows are gone. Now, in fact, every single action that you can do on this UI on top of the database is actually done via an SQL command. So an easy way to see that is actually by looking at this particular part of the adminer console, which shows us the SQL query. So for example, if I edit this and change the category to work, you can see that the item has been updated. You can click on the SQL command and you will see the SQL command that the web app is issuing to the DBMS, right? So you can learn SQL basics just by making requests here. For example, if you want to select by a particular value, so let's say I want to select where ID less than 10 and ID greater than 4, right? Let's say we make this query. Right, you get 2 values and you can see the SQL statement that is going to make this query. So that's the SQL statement. Let's now look at a slightly different kind of query. Let's look at a query where we can fetch information from multiple tables in the same request. And that is a very common use case. For example, if you look at the article table, if I fetch data from the article table, I will only get ID, title, content, author ID, and category. But suppose I also want the author's name. How will I make that query? I don't want to Making 2 queries is a bad idea. I don't want to make a query to the article table and then make a query to the author table and fetch that information. Because if the data set is large, for example, if you imagine a few thousand articles, I would have to make 1 query to fetch the 1,000 articles, and then I would have to make potentially up to 1,000 more queries to fetch the author information for each author, right? But I want to fetch all of that information in one shot, and so let's see what that query looks like. I can say select star from article comma user where article dot author ID is equal to user dot ID. Note that it's important to use the double quotes around the user table name because user is a special keyword in Postgres, and so it's important to add the double quotes here. So If you say select star from, so I'm saying select all the columns from both these tables where article.author_id is equal to user.id. And so if you execute this, you'll get all the author information here as well, right? So you're getting author ID 1, you're getting username, name, email, right? And so now you can choose what columns you want. So for example, you can say you want article.id, article.title, and then I want the user.username, user.name, right? And if these are the columns that you want, you can make a query and you can just get those 4 columns, right? So this is how you can fetch from multiple tables in the same shot. Now this is a very, very, very simple example, and what we're actually doing here is something called a join. So this is a shortcut for doing something called a join. Joins allow you to fetch from multiple tables across several conditions. Let's now look at another interesting kind of query. Let's go back to our article table. Let's clear these conditions on the cross arrow, right? So we have 4 articles. Now in these 4 articles, I want to make a query to fetch the number of articles written by each author, right? So in this case, the result that I want is author ID 1 has written 3 articles and author ID 2 has written 1 article. So the information that I want to fetch is how many articles are written by each author. Let's look at what that SQL query looks like. So I can say select author ID, right, and count of star from the article table, right, and group by author ID. So you can see that we've gotten the result. So let's read this SQL quickly. We're saying select the column author ID and count of star, and we'll understand what this is in a bit, from the table article, but instead of just fetching all the data from the table article, take the data from the table article and group it by a particular column's value. So group it by the values of author ID. And if you look at author ID, there are only 2 values. So it groups it for the value 1 and groups it for the value 2. Once you group a particular table, the only column that you can select is by performing what is called an aggregation on it. So here we performed a count aggregation to get the number of articles that are written by this particular author. So these queries are called aggregations or group by queries, and group by queries can be used to perform a lot of complex analytics on the data that you store in your database. Let's now look at something very different. Let's now actually create a table by using SQL. And what we'll do in this case is that we'll actually just use add minus. So we will go to create table and we'll say create a table called SQL test. Give it a column called ID, which is an integer, and a column called name, which is a text, right? And save this. If you look at the create command, you'll see what the SQL is. And so let's copy paste this SQL and put it into our command window, right? And let's change this to some other name, SQL test 2, right? And if we run this query, so let's read what this query says. This query says create a table and the table name with the following columns. So create table SQL test 2 with a column ID and name. The ID column is an integer column and null values are not allowed inside this column. The name column is a text column and no null values are allowed inside this column. So if you click on execute, you'll see that another table has been created. Similarly, we can drop these tables, or rather we can delete these tables, and the way to delete these tables is called a drop. So let's do a drop table SQL underscore test. You can see that the table has disappeared. Let's drop SQL test 2 and it's dropped, right? So this SQL statement deletes tables. So this is called dropping a table. In SQL, you would typically refer to deleting a table as a drop. You would delete a database. You can also delete an entire database by doing a drop database. But when you delete a row, the SQL command is called a delete, not a drop. So this was just a super fast introduction to what SQL is and what the power of SQL is. I did not go into any syntax to explain to you what the SQL language itself is and what the syntax of the language is, but the idea was just to go over a few fundamentals of what the power of SQL is. I would encourage those of you interested in the backend development side of things and interested in databases to definitely learn SQL. SQL is almost one of the prerequisites for doing complex analytics and for analyzing databases and managing databases. The important things to remember after this from this module are, number one, what the SQL syntax looks like, and that the SQL language is extremely powerful, and every single thing that we do via the UI on Adminer is actually happening via an SQL command. The indexes that you make, indexes that you delete, the primary keys that you make, when you change a type of a column, when you insert data or search for data in a particular way, all of those are SQL commands. SQL is a standard way of talking to relational databases, and in fact, Postgres, MySQL, Oracle, MS SQL Server, Sybase, all of them respect the SQL standard. Each of these databases differ a little bit in the particular version of SQL or the particular syntax of SQL that they use, but the core language is the same across all of these databases. A lot of other databases which are not relational databases also support SQL. Up next are several quick theory modules on thinking about performance in databases, especially touching on indexes, security, backup recovery, an introduction to transactions and ACID, which are very important for financial applications or e-commerce applications, an introduction to views analytics. We'll also look at the differences between NoSQL and SQL systems, and then finally look at how we can scale a database or how databases are scaled vertically and horizontally.